Hello everyone. We're going to take up the next 10 questions of KCET 2022 chemistry paper. So this is the continuation of the previous video. You can check out the previous video if you have not seen it earlier. So let's continue. 11th question. Which can absorb larger volume of hydrogen gas? This is a theory based question. Uh, for absorption of any gas, the catalyst should have surface area. More the surface area, more it can absorb. So in these options, palladium has maximum surface area. So it can absorb largest volume of hydrogen gas. Hence, option C is the correct option. Let's move on to the next question. Property of halogens which is not correctly matched. So first one is electron gain enthalpy. Electron gain enthalpy in halogens is in the order chlorine is greater than fluorine, then bromine, then comes iodine. This interchange in position between chlorine and fluorine elements is due to, first of all, fluorine has a very small size and it is highly electronegative. And chlorine has larger size comparatively, and the electronegativity is low due to its size, as in fluorine there is repulsion between the 2p orbitals, right? Chlorine has more electron gain enthalpy than fluorine. So I hope you understood the reasons why it is like this. We can see the option A, they have interchanged the position. That's why this is the wrong one. As in question also they had asked which is not correctly matched. So option A is the answer. 13th question. Which noble gas has least tendency to form compounds? Krypton, helium, neon, argon. Option B is the right answer. Why? This is because all the noble gas have full outer electrons, right? So all because of that, it is stable in itself. So it doesn't want to form compounds with other elements or compounds. So and helium, it has no p orbital. It doesn't have p subshell itself. So it is having the least tendency to form compounds. So B is the right answer. Okay. I hope it is clear. Let's move to the next question. NH4 twice Cr2O7 on heating liberates a gas. The same gas will be obtained by. Okay, let's take on this reaction. On heating liberates a gas. So we'll write the reaction. It becomes N2 plus Cr2O3 plus 4H2O. You can find the reactions by balancing the left hand side and the right hand side to balance. If you balance it out rightly, you will get the correct answer in the product side also. So nitrogen is the gas that is liberated. We'll check in the options which option has nitrogen evolving in it, right? So option A is treating Mg3N2 with water. Mg3N2 with water gives 6 moles of water will take, and this will give 3 MgOH twice plus NH3. Twice NH3. Yeah. So we don't get N2. Nitrogen gas is not released. So this is not the answer. Let's see option B. Option B says heating NH4NO3. NH4NO3 is heated. So we'll get N2O plus 2H2O. Here also we are not getting nitrogen gas. Option C. Heating NH4NO2. NH4NO2. If we heat, we'll get nitrogen with 2 hydrogen water molecules. So this is the right answer. Still, we'll check the last one. Treating H2O2 with NaNO2. This becomes NaNO3 with H2O. So the right answer is option C. We have to check all the options for this type of question, and we have to draw the reactions to find all the products formed also. Next question, 15. The complex hexamine platinum 6 4 chloride will give dash number of ions on ionization. So hexamine platinum. At this stage, you should be, while writing competitive exams, you should be capable of finding the chemical formulas by just reading the names of compounds and also the reactant from the product or vice versa. So 15th one. So we are finding this. So the question is, we have to find the number of ions it will give on ionization. When we ionize this compound, what will we get? So when we ionize this, this chloride, it will dissociate. So we'll get 4 ions of chlorine. And here, this ammonia will not break from platinum. Why? Because it is already in the coordination sphere. So it will not dissociate. Okay. So it will come out as a whole. So this will break down as only one. So total we'll get how many ions? 5 ions. Question number 16. In the following pairs of halogen compounds, which compound undergoes faster SN1 reaction? So, okay, pairs are, we'll take up the first pair, okay? The first pair is this and this. Second pair is this and this. Okay, so in SN1 reaction, there is this relation, okay? You should know this relation, okay? Which says SN1 is directly proportional to the stability of carbocation. More the stability, faster is the SN1 reaction, right? So if you know this relation, we need to find the carbocation of this, 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 and this. In this question, it says which among these two is faster and which among these two is faster, right? So in this, the carbocation will form as this, correct? And for this, it will be this. For this, it will be this. And for this, it will be this, right? So we need to find which is stable. How you will know the stability of a carbocation? This is a 3-degree carbocation, or it is tertiary carbon. The plus charge is on the tertiary carbon as it is attached to 3 bonds, right? So this is more stable than a secondary carbon. And here, it is a 2-degree or secondary carbon, which is more stable than a primary carbon, right? So this is more stable than this. So we'll check the options. We can see option C has this one as the most stable one and this one as the most stable one, correct? So next question. Question number 17. This is a theory-based question. The only lanthanoid which is radioactive, that is promethium. Next, let's move on. This is a theory question, so you have to remember it. Next, 18th one. As in promethium, we know like all the isotopes are radioactive. So promethium is the only lanthanoid which is radioactive. Next, 18th question. All copper-2 halides are known except the iodide. The reason for it is that this reaction takes place, and we know that other halides of copper like CuBr, CuF, all of these are present. Only the iodine is not there. Why? Because the iodide gets converted to iodine. And copper oxidizes iodide to iodine. Hence, there is no copper iodide possible. So let's move to the next question. The correct IUPAC name of cisplatin is diamine dichloridoplatinum 2. Is the correct IUPAC name of cisplatin. And it is also used in treatment of cancer. This is a theory-based question. It is in NCERT. It's an important question, so everybody should know. Let's move to the next one. This is the 20th question. In this, they have given the crystal field splitting energy for an octahedral chloride is 18,000 centimeter inverse. The crystal field splitting energy for a tetrahedral chloride is to be found. There is a relation. It is an important relation. It is mostly, again, this is a JEE level question. It is asked like 20th question. So we know that CFSC, that is crystal field stabilizing energy for octahedral and tetrahedral is 4/9 delta naught. Okay, so that is COCl4 2 minus is equals to 4/9 delta naught. What is delta naught? Delta naught is the value that is given, that is delta naught is equals to 18,000 centimeter inverse, right? In this question it is given, na? This is delta naught. Okay, so we'll put it in this formula, 4/9 into 18,000. 8,000 centimeter inverse is the CFSC of octahedral chloride compound. I hope this session was helpful to you all. In the next session, we'll be taking up questions from 21 to 30. So please do subscribe to our channel for more updates. Thank you.